This will be a review of Unit 4's self-assessment. And again, we want to find strategies for this. Now, 2 fair 6-sided dice are rolled. What is the probability that the sum of the 2 numbers is a 5? For something like this, I hope you have this in your notes, which is a portion of that results from rolling die. They should be 36. We only needed to find the combinations that produce a 5. And there's 1, 2, 3, 4. So 4 out of 36, which is 1 out of 9, which is what this person had. Now, here we have an individual. We're having respondents. There were 113 that had a car accident. 178 did not have a car accident. So the sum of these two would be our sample space. But we're wondering how many did have a car accident. Our sample space, those that had a car accident, do the division, round to 3 decimal places. We drop the 3, and there is our answer. Now in this one, we're looking at the distribution of BA degrees, and we're wondering how many had engineering, and what would be the probability you selected someone from engineering. So we look and see we had 868, and then they do the total for us, 900 or 9,313. And when we do the division, this comes out nicely here, 0.0932. Okay, that one was pretty straightforward. This example is in odds against spinning a D. Well, as we look at our wheel here, we have just one D here. And what is our sample space? Well, there is 1, 2, 3, 4, 5, 6, 7, 8. And the odds against spinning a D, they would be 7 that are not D. So this would be the probability. But now, what would be the odds? Well, against would be 7, and then you have to subtract the 7 from the 8, and that leaves you with 1. So again, pretty straightforward as long as you recognize we're looking for odds here. All right, it's been determined that the probability of an earthquake occurring on a certain day in a certain area is 5/100. What are the odds against an earthquake? Well, that it would occur would be 5 out of 100. That it would not occur would be then 95 out of 100. This is the probability. Now, putting that in odds, we would go 95 to 5. Now, notice this is not one that's available here. So you have to simplify, dividing each of these by 5. This would then be 19 to 1. In this example, a bag contains 6 red, 3 blue, 1 green. If a marble is selected at random, what is the probability that it is not blue? Well, again, we have to find our sample space. So this is 6 plus 3 plus 1. And we're looking for not blue. Well, if we went for the blue, this would be 3 out of 10. But we're looking for the complement. So the complement of this would be 7 out of 10. That is not blue. So 7 out of 10. And again, this is for strategy. You're going to read the items carefully, decide your modus operandi, that is how to get the answer, and then move toward it. In this example, a fair die is rolled. What is the probability of rolling an odd number or a number less than 3? So your odd numbers would be a 1, a 3, and a 5. And a number less than 3 would be a 1 and a 2. Well, the 1 is already there, so you'd have to add a 2. So this would be 4 choices out of a possible 6. So this reduces to 2/3. And the protocol to get your answer. In this example, they want you to select a student between these areas, 26 and 35. So you go to your chart, 26 and 35. So what I blocked off, we add this. They're giving us our sample space. We do the division, and the answer is straightforward. Again, good practice, reading carefully and then deciding on your strategy. This is one we did earlier, very similar. Again, you look for what they're asking. English and math, add these two, put over your sample space and find this. So we're not going to spend a lot of time looking for strategy. We did one like this. Now in this example, we shortened it somewhat so that we've done some pre-calculations, adding up our horizontal lines. They all add up to 85. So if one of the 255, which is our sample space, is randomly selected, find the probability that the person is over 40 years of age. Well, over 40 years of age would be this row, which is 85, over this, due to division, and it comes out 0.33, and they just keep repeating, which is the fractional form of 1/3. Again, knowing the protocol, not too challenging. All right, in this example, they're giving you a data chart. It says if one of the 87 flights is randomly selected, find the probability that the flights selected arrived on time, given, now this is a key word here, because this then puts it in the conditional, that it was an upstate airline flight. So we're only interested then in this one. And we want it to be on time. So that would be 43 out of your total 48. Again, this is given. That makes it conditional. In this example, in a city, 17% of the people drive Cadillacs. 21% of business executives drive Cadillacs. Are the events person drives a Cadillac and a person is an executive independent? And the answer is no, they're not independent because they are interrelated. You have an intersection in a sense of these. All right, let's go on. A card is selected at random from a standard deck of 52 cards. It is then replaced, that's the key here, and a second card is selected at random. Are the events club on the first draw, ace on the second draw independent? And the answer would be yes. And why? Because the card was replaced. You have uniformity criterion going on here in the background, if you remember that word from an earlier lesson. This one, from a group of 3 men and 4 women, a delegation of 2 is selected at random. What is the expected number of men in the delegation? Round to the nearest hundredth. Well, in reflecting this, this person had it selected incorrectly. You might say, what would be the background strategy? And this is a little challenging. Well, you have a total of 7 in the group and 3 men. So that you would have a man at any particular selection is going to be 3 out of 7. Well, that would be the first person. And then, in a sense, that same ratio, 3 out of 7 for the second man. And it would be that throughout the selection, if you put the persons back in the group, although they're not saying that. But if you added these together, you would get 6 out of 7 for a selection of 2. And then that approximates 0.86 is the best way that I could possibly explain how to figure this one out. Now, for this one, as you look at it, we want to consider what is the expected profit. Well, if we take 70% of this, which is what we have here, and 30% of this, which is what we have here, this would be loss. So if we subtracted the loss from the expected profit, or profit, we would get the expected profit, which is 20,300. And again, this was challenging, but we did do some like this. In this example, and we have a profit in a sense of 500. Selling raffle tickets, you can win 500. That's the trip. They're sold at $1 each. Find the expected net winnings for a person who buys 1 ticket, round to the nearest cent. So, what's your expected winnings here? Well, you're going to have 500 out of 3,000. So the winnings would be, and you can drop all these off here, this is 1 out of 6. So for every dollar you spend, you can expect a return of 1 out of 6. But you're spending $1. So every time you spend $1, which I'm going to list now as 6 out of 6, this is your, in a sense, cost. You're going to gain this much. So in a sense, you're losing 5 out of 6. So for every $1, there's a net loss. This is a loss of 5 out of 6. And if you convert that to its decimal form, that would be 0.83. But again, it's a loss, so we put a negative by that. And that's what this is showing here. But again, you have to find out what the gain is. So in a sense, the converse of that, or the complement of that, is the loss, which is 5/6. Now, this next example, the individual had it incorrect, but what would be the protocol for solving it? Well, again, you're looking for expected value, and we said we get expected value by multiplying this value here by this probability. So this one is 0, and I'm going to do all of these. So multiplying each of these probabilities by the value give you this, adding them up, it's 3.60. So again, the individual doing this may have had a calculation error somewhere in there. It's just a little tedious, but this would be the protocol for getting the answer. Now, this example is very similar to the previous one, set up a little differently, and let's look at it. So again, this is the item. This is the probability. We have to multiply these. This 0 times anything is 0. 1 times this is this. Now, 2 times this is just 2 times 3 is 6 sixteenths. Then 3 times 5 is 15 48ths. 4 times 1 is 4/8 here. 5 times 1 is 5 24ths. And just put that into your calculator. This plus this plus this plus this plus this. Hit enter and you get 1.666, which is a repeating decimal, and it rounds off to this. So again, the person guesstimated maybe, but this is the actual protocol to solve it. Now, this last one is sort of a challenge, and suppose that we wish to distribute the 2-digit random numbers from 00, which we're calling a number here, through 99, such that the corresponding random numbers can be used to simulate the sighting, which is an unidentified flying object in a given region. If the numbers 00 to 40 correspond to 0 sightings, what is the estimated probability of 0 sightings? Now, again, how many items do we have here? Well, this is 1. It's just a simulation, and up to 99. So the key here, as I see it, is that there are 100 simulations. Now, how many does this represent? Well, remember, this is 1, and then it goes up to 40. So there are, in a sense, 1 through 40 more. So there's actually 41 here. So again, this was sort of wordy and hard to analyze, and there is the answer. Again, once you see the answer, it's kind of a little bit easy to figure out, but looking at it and trying to figure it out, that was the challenge. Well, hopefully these were helpful. That's what they were meant to do, and give you some insight to items in Unit 4.